Hello, in this video let's discuss third question of today's contest. You are given two integer arrays nums1 and nums2 each of length n. You may perform the following operation any number of times on n1 on numbers 1 the first vector. Choose the subarray L2R, remove that subarray leaving the prefix and suffix, reinsert the removed subarray at any position in the remaining array. Return the minimum number of operations needed to transform nums1 to nums2. The constraints are n is up to 1 is 6 and the values are minus 1 to 1 and the v2 is surely a permutation of v1. So n is less than or equal to 6. So what are the total number of transformations possible? They are 6 factorial, because let's say we have 3 ABC, and what are the total permutations we can have? ACB, BAC, BCA, CAB and CBA. So 6 which are 3 factorial. So similarly for 6 the total number of permutations are 720. So the only total possibilities are 720. So what can we think? So let's say this is the first vector, and then let's select any subarray and do the operation. We'll get many different choices. By selecting 0 and 3 subarray, we can insert this at any position after index 4 or after index 5 or after index 6 and so on. Similarly, if we take 2 and 7 subarray, if these indices are existing, we can add at 0 index, first index, third index, 8th index and everywhere. So for every removal we can have many different possibilities. So we can draw something like this. Let's assume that this is the vector 2. This is the nums2 we got, and the steps are 2. So from this we can get that we are going to use simple BFS, because it is used to find the shortest or less number of operations to reach a configuration. And why we are sure that BFS can work here? Because if we find the new subarray, if we find the new vector in second operation, we can simply return this. There is no possibility that it is found already earlier or it is found in the later operation with better configuration, because this is what we exactly wanted. If there is some choice with this, for example, if the question states that we want the new vector with some other extra thing, then BFS is not straightforward. But here, if anytime if we reach the array, the v2, then we can simply return operation without thinking anything. Because if we reach this, it means that we did not reach till before operation, and then we don't care about future operations because we got at the lower operation. So we can use BFS. And what is the state that we have to track? It is simply vector, because the length is up to only 6. So there is no problem even if we store the vector. So q of vector and the number of states. We cannot maintain this in state, but let's maintain here because it is very less. Even time complexity will be very less also. So the q of vector that we are at, the nums1, and then the steps required to reach this. And initially what will be the first thing that we are going to add to q? It will be simply v1 comma 0, because v1 is initially there, and 0 because no need to do any operations to reach v1 itself. So this is the first one that we need to push into q. And now let's think what are the cases or what are the things that we have to do from one state to next of the states after doing one operation. So let's assume that we are going to select L2R subarray. So if we are selecting L2R, what is the new array without L2R subarray? What will be the length of the new array? It will be n minus this much, because we are removing these. We will add this anyway, but for now let's assume that we are removing this. This is the new size. So now where we can insert the where we can add the subarray L2R in the newly array formed after removing L2R. We have many different possibilities. So let's say this is the new vector without L and R. So let's assume that this is in the middle and we remove L and R. So now what are the choices that we have to add? We can add simply before the first element, we can add after the first, we can add after the second, and we can add anywhere. So let's say we have four size subarray after removing L2R. And what is the choices that we have? What are the number of states that we can get from this? So we can add before, we can add in the middle, 3, 4, and then 5. We don't care about the position where L2R came. Let's assume that the L2R is here. So even if the L2R is here, we will try to check this, because we are already storing the q of vector. So similarly, we can store a q visited vector, so that we will store whether a vector is visited or not, the whole vector. So if we are storing the visited, then no need to care about this. We can traverse all the choices, and then finally we can check whether the vector is already visited or not. If it is visited, then don't do anything. If it is not visited, then simply add into visited and then push the whole new vector into queue. The space complexity will be less because it's only 6 factorial. So we have these many different choices. So we'll add into this and then it is very simple. So we'll just add into this, we'll get the new vector, we will check whether that is visited or not. If it is not, then add into queue, add the new vector into queue and then increase the answer. So old answer plus 1. So now what are time complexity and space complexity? Let's assume the array size is n. So if the size is n, what is the total time complexity? So the number of states will be n factorial. So just we can try to assume that this is BFS will run for n factorial times. This is very far more than the real, but this is the worst time complexity that we can have. So n factorial is the iterations that are required to do BFS that many times. And now in a single BFS, what is time complexity? So in a single BFS, firstly what we have to do? So firstly we have to select L and R that we are going to select for the present operation. Because we can select any L and R any number of times so that this can be removed and this can be added anywhere. So the first thing is we can select any L and R. So the time complexity to select this will be n square. And now after getting selected L and R, so let's say we got L and R, and now what we have to do? So now the main thing is after finding L and R, we also have the new array without the range L2R. So let's assume the size is k. So let's say size k is the count of elements in the array without after removing L2R subarray. And now where can we insert L2R? So we can insert in k plus 1 different places. Maybe each one is a not new vector, but these are the number of possibilities that we have to add L2R. So we will go through all the indices and then we will try to insert that into that index. So we require other loop from 0 to k and then let's say we assume I. So what does I mean? So I mean that we are going to add after index I L to R, and this is the I plus 1 originally, and 0 to I minus 1 is also originally intact. So the only array change is after the index I we are going to add subarray L to R. So we added this also, and then so we chose index I. So after choosing index I, we want other loop so that we can insert the whole L to R which we found earlier to this. So we create other loop, and then we will add into this, and then after these we will get the new vector, and then we will check if it is visited. If it is visited, then don't do anything. If it is not visited, then make it visited, and then push q comma this new vector and answer this one. What will be the time complexity? So total number of BFS are n factorial. Just let's assume, and then n square subarrays we have to select L and R, and then for every selected L and R we have to select an index where we are going to add the new subarray, so into n, and then we have to actually add L to R, which is often. So n factorial into n power 4 is the time complexity. And then coming to space complexity. So what are the things that we are going to store? The only thing we are storing is BFS and visited. So what will be time space complexity for that? N factorial for the total number of vectors and then into n, because n is the maximum number of operations. Why maximum? Because the v2 is always a permutation of v1, so we can do element wise. Let's say we have these three and we have 1 2 3, so we can select element wise and then we can follow the answer. Like for example, if the array is 2 1 2 3 and it is 2 1 3, let's assume that we are not going to do any operation. We are trying to find the maximum number of operations which are less than or equal to 3. So we can just select 2. L and R is equal to 2 1 2. So we'll select this and we'll insert this here. So now 2 1 3 directly we got. But the maximum operations is 3, the size, because we can select every element once and then we can insert the first. For example, let's say we have ABC, and then EFG. Let's assume EFG is the permutation of ABC. So what can we do? If C is equal to A, then we can simply select C and we can insert this beginning. And if B is equal to F, we can select this here. If this is equal to A, then we can select this. So by 3 operations, we are going to make sure that we are able to find an answer to reach V2. So if there are in BFS, we will surely return the answer. But for the safe case, if we are not returning, then we can simply return it so that we can make an operations. So this is the queue and this is the vector of set. We are storing this so that we will not move in loops, and simply initially push v1 comma 0 and visited v1 into visited, so that v1 is initially the vector itself, so it is already visited. And now start traversing, start doing the BFS, and then pop out the vector we have and the answer. And if the current vector we are at is v2, then return answer because we got the answer. And then loop through L and R because we first want L and R. So two loops for finding L and R, and then find the new vector L and R. So we got L and R. So we have to get the array subarray L to R, L base 1, L base 2 and so on. So the subarray will contain now the numbers from L to R. So plus 1 it will be subtracted again. This is the after one. So we'll remove this. So it will be simply L to R only. And then what will be the new rest subarray? The rest subarray is without the L to R. So simply start from 0 to L, add all elements. Start from R plus 1 to N, add all the elements because we are removing L to R. So L and R, L minus 1 and R plus 1 will collide. So this will be the new rest subarray. And then now we have k different choices to add L to R. So now we can start traversing all the k possibilities. So 0 to rest dot size. So let's say we have 3. What are the choices we have? We have 4. Before first, middle of first second, middle of second third, middle of third fourth, and then after fourth. So for n we have n plus 1. So 0 to 0 less than or equal to size. And then just make the new subarray. And then let's say we selected k. So let's say we selected k. Then what will happen? So the elements from 0 to I minus 1, k minus 1 will remain intact, which we discussed, and it is very easy to think. So we'll just simply add all this, and then at I. So we are at k now. So we are at k. So we should add L to R. So we add all the elements from till less than k, and now add all from L to R, and then start traversing, adding again from k to rest array. So we are just, let's assume that this is the selected index, and we are adding this to new vector, and we are adding L to R, and then we are adding all these back again. So after this we will get the new vector, new vector next, and if it is not counted, then simply add and then push answer plus 1. If they are not visited, then we don't do anything. And after finally we will surely return some answer, but for safe case let's return n, so that if we are unable to find the answer from BFS, we can use brute force, or like we can select every element and we can make sure that we are, but that also will be covered in BFS, but let's assume. So if you are not, comment below. See you in the next video.